You know, along the way, they should be responsible for making some drawings and writing down a process, fabrication process, because if you can write this down before you actually get in there and start doing it, it's, you know, it saves a lot of energy.
I don't think there's anything more important than designing great assessments right at the beginning. So the third module, Plan the Assessment, is about thinking through very carefully what you want your students to know and do at the end of the project and how you're going to assess them.
On March 24th, you're going to stand in front of your peers, you're going to stand in front of your parents, you're going to stand in front of a panel of engineers, and you're going to say, here's our wing design, this is the one we recommend, and here's why. You will have data, you will have graphs, you will have a clear presentation with clear roles, and you're going to knock the socks off people.
You could have everything in before the test is done. You could have them make a prediction of how strong they think it's going to be. They can have measured it in advance, and then they can discuss about the way that the thing failed and how they thought it was going to fail versus the way it really did fail.
Yeah, and see, I think that would be very powerful. We start with an abstract. Here was our wing design. Here's why we thought it would work. Here's how we built it. Here's what we thought would happen with the actual model. Here's what actually happened. Here's why. And that might take the form of an interview. It might take the form of a formal note. It might take the form of a postie. You know, I don't know. With team responsibilities and communication, use a teamwork rubric, measuring things like, did you have team norms? Did you have team responsibilities? Was it very clear from the outset? Here are the list of skills that we need, and here are the gifts that you bring to that group.
Are you going to have something about the correctness of their science understanding in there, or is that going to be evident in the design process?
It will be in the product. It will be in the final product, like a formal lab report.
And so we're still missing the 2x4.
Okay,
so
and we can get that for you if you can add it in.
Yep.
Most projects culminate in some kind of end product. Rubrics or criteria that measure these products inform the teacher and the student of what is expected of them and how well they've met those expectations.
I would like to encourage you to draft a design process rubric that can be used for other design projects. Okay. That it not be project specific, so that we can avoid rubric fatigue by using one rubric most of the time rather than always crafting as project specific ones.
I'm right there with you.
Are you going to have the kids evaluate themselves?
Absolutely.
Okay, so is it going to be teacher evaluated or just student peer self-evaluation?
Both.
Okay.
What I anticipate is that there will be a triple column. My group, myself, my teacher.
Okay, great. That's important to identify who's doing what part of the assessment. So what I'm hearing you say is if it's the design process that you want to assess, you'll use a variety of assessment tools. One of them is the design file you're asking kids to keep. And you'll be looking for certain things to be in there, like notes, initial designs, something jotted on the initial design of why they went with it or didn't go with it, this kind of thing. Something that gives you evidence of the thought process they've been through. Okay, so it's a record.
Yep.
So that we don't just have this wing design appear out of nowhere. You're also talking about using an interview. I'm assuming that's you with the kids?
I think, well, when I thought about it in my head, it was me with the kids.
Yeah, that's great.
Depending on your availability, Doug, I think that would be a very powerful piece for you to come in. I mean, if you have that kind of time or interest, to come in and say,
I think we can work that out.
That's perfect.
Engineer Doug Gross drafted his colleagues to serve as judges for the students' presentations.
So I've included in your packet the criteria, front and back, and there's one for each group for each judge.
Okay.
All right.
One of the most powerful ways that you can use to get really good performance in projects is to choose an audience outside the school and to choose an audience of adults. Anytime students get in front of adults, their performance usually gets a lot better because, like anyone else, they want to look good in front of an audience.
Our task for this project was to create a high-efficiency, low-weight wing that, when tested, would, it would show the values you'd want for a real wing.
Using a criteria scoring guide provided by teacher Scott McComb, the engineers rated each team in categories that ranged from design process and technical performance to reports and presentations. The guide was just one of many factors that went into a student's grade for the project. They were also assessed on their efforts by their teammates, as well as on their completed design files.
These kids the way they present themselves. They're articulate, they know what they're about, they know what they've learned, they've obviously been able to work together. And in a situation like this, for ninth graders to pull off something like that is absolutely remarkable.